Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video I am going to discuss about complete description of moment of force, that is representing the turning tendency of force. So let's start the description of moment of force. Basically, moment we considered as the force into distance. This is the definition, or we can say this is the formula of moment. Moment is always represent the product of force and the distance. So if we want to define the moment, so moment is represented as the turning tendency of force about a point. That's why we represent moment as force into distance, and that particular distance we considered perpendicular distance from a particular point. Let us consider a force which is moving along a curved path or which is turning along a curved path. So here you can see a diagram. This is the body. Here you can see this is the body, and if we are considering there is a force which is acting on this particular body, that is P. This P force we are considering the force which is external force acting on the body, and if this force is turning with some angle like this here in this particular direction, or that direction can be opposite also. So this is moving along a curve. Here there is a turning we are considering for this force, or rotation of force we are considering. So rotation we always consider with respect to a center point. So here if we are considering this point O is the center point of the curve about which that particular force is rotating. So this is the point where we are considering the distance. This particular point and this particular point is representing the vertical or perpendicular distance of this force about this point of rotation. So this O is represented as the point of rotation for this particular point, and this force is moving in this particular direction. So this rotation of force in a particular direction is considered as the moment. That is why we can say the moment is the turning tendency of force about point. About this point A, this force P is rotating. So as per this concept, we can define the moment as force into perpendicular distance of line of action of force about the point. So this particular distance we considered the distance of line of action of this particular force. This is representing the line of action of the force. This particular line here I have drawn. So this particular line is representing the line of action of force, and the distance of this line of action of force with this point O about which the force is rotating. So the product of force and perpendicular distance of line of action of this force about point O is called the moment of force. So we can write this equation as force into distance or perpendicular distance. Here you can see the another diagram. So this particular P is represented as the force, and this point O is the point of application where we are considering the moment, and the distance of this O and P is represented as L. So as per this equation, this will be the formula of the moment. M equals to P into L, where this point O is called the moment center. This L, the distance of O and P, is called the moment arm, and the product of P and L, this force P and this moment arm. So this is representing the moment, and we know the unit of force, that is always Newton. So the moment unit we consider as Newton meter, because Newton is the unit of force and meter is the unit of distance. So the total unit of the moment will be Newton meter. So this is about the moment, and here this P is representing the force which is acting on the body, and L is represented as the perpendicular distance between O and line of action of the force. if we want to define the direction of movement, like if we are defining the direction of force, so the force is always positive in forward direction and the force is always considered negative in backward direction, or downward force we consider positive and upward force we consider negative. So this is the sign convention we generally consider for forces, and these sign convention can be opposite. It's up to you, whatever sign convention you want to take, you can take that sign convention, but you have to keep that sign convention during all your concept or during the solution of your numerical. So whatever concept you want to take, you can take that according to that. So here, if we want to define the direction of movement, so direction of movement will be depends on the direction of force. So here you can see in this diagram, this O is representing the moment center and P is here, you can see P is moving in downward direction, and if we rotate this particular force according to its direction, so this force will rotate like this, and this rotation is generally representing the moment. So this moment will move in the direction of force or where the force is rotating. So this particular moment will move in this direction, and this direction is represented as the clockwise direction. And if we are considering clockwise movement, so that particular, if we want to take sign convention, so clockwise movement we will take as negative. Opposite to it, if the force is moving here in this particular direction, you can see here this is the direction of force. So as per this direction of force, if we rotate this force about point O or about the center, so this force will move or rotate in this particular direction, and this direction is representing the anti-clockwise direction. So the moment we will consider here in this direction, in anti-clockwise direction. So anti-clockwise direction we will take always positive. So as per this, we can define the direction of movement, like anti-clockwise movement we will take positive moment and clockwise moment we will take negative moment. We can consider opposite also, anti-clockwise we can take negative or clockwise we can take positive, but we have to stick on one concept. Either we can take first condition or we can take the second condition as the direction of movement. Now here you can see another diagram. Here we are considering a line AB which is represented by the magnitude and direction of the force P. Here this is the force P which is applicable in one particular direction, and this AB is represented as the magnitude and direction of this force P. And if we are rotating this particular force P in a particular direction like this, and here this point O is represented as the moment center about which this force is rotating, and here if we draw a perpendicular from point O up to this line AB, so this is represented by OM. So if we want to find out the equation of moment for this particular condition, so our equation will be, or we can find out the moment of force about this point O will be P into OM. This will be what? This will be P into OM. P is the force and OM is the perpendicular distance. Now, if we consider this diagram as the triangle OAB. So this triangle OAB is representing the condition of moment where the force P is rotating about this particular point O. So we can write here this term P into OM as AB into OM, because this P is generally equivalent to AB. Here AB is representing the magnitude and direction of force P. So this P will be equals to AB and OM will be the perpendicular distance. Now if we simplify this equation, so this equation will be 1 by 2 AB into OM into 2. We will multiply 2 and we will divide this equation by 2. So here this term 1 by 2 AB into OM is representing this area of the triangle OAB. Here you can see this triangle OAB. So this 1 by 2 AB into OM is representing the area of triangle, and this equation will be 2 into area of the triangle OAB. So we can define the moment of force with this particular concept of triangle, like the moment of force about point A is equals to twice the area of the triangle which is having base AB equivalent to the force which is applicable on any body and the force which is rotating about point O, and the moment center is represented as the vertex of the triangle. So the area of this particular triangle multiplied by 2 will represent the moment of force about point O. So this is the concept of moment. Now let's see one example which is related to concepts of moment. Here you can see a diagram. Here we are considering a center O, and this is the moment center we are considering, and there are number of forces. Force F1 in this particular direction, force F2 here in this direction, force F3 is here, and force F4 is here. And if we are considering the distance of force F1 with point O is x1, the distance of force F2 from point O is x2, and distance of F3 from point O is x3, and distance of this F4 from point O is x4. So this is a diagram, and we have to find out the total moment for this particular condition. So the total moment will be what? The moment or the summation of moment of all these forces. So if we find out the summation of moment for this particular condition, so it will be so the equation will be F1 x1 minus F2 x2 plus F3 x3 plus minus F4 x4, that will be equivalent to summation of moment. For first force, the force is F1 and the perpendicular distance from point O is x1, so it will be F1 x1, and it is acting in anti-clockwise direction, so this term will be positive. Second term will be negative, it will be F2 x2, and it is acting in clockwise direction, so it will be negative. Third term is acting in anti-clockwise direction, so it will be positive with F3 x3, and fourth is F4 x4, and it is acting in clockwise direction, so it will be negative. So F1 x1 minus F2 x2 plus F3 x3 minus F4 x4 will be the summation of moment for this particular condition. So this is a complete description of moment. Thank you so much for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.